Hi students, welcome back to the online classes. This is the third session of the lesson force. So previously we have seen the different types of forces. What are the different types of forces? Let us look into the some tree diagram for that. So types of forces. Types of forces. So there are mainly two types of forces are there. One is contact forces and another one is forces at a distance. Forces at a distance, or we can also call this as or field forces or field forces. So there are four different types of contact forces are there. One is muscular force and another one is frictional force and normal force, tensional force or tension, just tension. And what are the three different types of field forces? One is magnetic force, electric force and gravitational force. So these are the different types of forces that we have learnt. So let us learn about net force. Net force. Net force. So what is meant by net force? The total summation of forces acting on the object is called as net force. So let us say I have an object here, I hold an object here. What are the forces acting on this? Sir, this is it, this object is at rest, that's why no forces are acting on it. No, forces are acting on it, on the object, but still it is at rest. Here I have holded some object, I have holded this object. What are the forces acting on this? This is the gravitational force. Gravitational force which is equal to weight. Gravitational force which is equal to weight mg. Weight is nothing but gravitational force. Weight is nothing but gravitational force. M is the mass of the object. It may be 100 grams or 200 grams maybe. 100 grams. M is the mass and g is the acceleration due to gravity. And that value is g is equal to 9.8 meter per second square. G is equal to 9.8 meter per second square, which is similarly equal to near to 10 meter per second square. 10 meter per second square. For example, this object is 2 kgs of object is there. So how much mass? 2 kgs into, let us take gravitation as 10. 2 into 10, 20 newtons. Newton is the unit of force. Newton is the unit of force. What are the units of force? Units of force are newtons. Newtons. Force is measured in newtons. Force is measured in newtons. So if it is 2 kgs object, how much force it will apply in the downward direction? Its weight is 20 newtons. Its weight is 20 newtons. So what is the force? What is the gravitational force acting on this object is mg. Mg is the weight which is equal to the gravitational force. So gravitational force is acting on this object in downward direction. So I have hold this object like this. So the weight of the object acts in the downward direction, which is equal to mg. But it doesn't fall. The weight is acting in the downward direction, but it doesn't fall. Why? I was applied some upward force. So here both upward force is there and downward force is there. What is the total force? What is the total force? So let us say this downward force is 10 newtons and upward force is 10 newtons. So what is the total force acting on this? It is not 10 plus 10 is equal to 20. The total force is not 10 plus 10. whenever you are finding the total force, it is not an regular summation. You cannot add like the regular numbers. You need to consider the directions also. You need to consider the directions also. That's why especially we will call it as net force. Net force, we cannot call it as total force. For the just for the explanation purpose only, I was explaining it as total force. Net force is similar to the total force, but it is not a as usual total. It is not a general summation. It is not a general summation. What is the total force acting on it? The total force acting on it is 0. The total force acting on it is 0. You need, while you are finding the total force, you need to consider the direction also. So how can you how can we consider the direction? So let us find the net force acting on this object. Let us find the net force acting on this object. In downward direction, what is the amount of force? 10 newtons. In upward direction, what is the amount of force? 10 newtons. So to include the direction, assign positive sign to one direction and negative sign to another direction. So let us take upward side as positive and downward side forces as negative. So you have taken upward forces as negative. So what is the force here? Plus 10 newtons. Plus, what is the second force? Downward direction you have taken as negative. So minus 10 newtons. So what will happen now? Plus 10 newtons, plus into minus, minus 10 newtons, 10 minus 10, 0 newtons. So the total force acting on this object is 0 newtons. So here you are finding, whenever you are finding the net force, which is nothing but which is similar to the total force. Whenever you are finding the net force acting on the object, you are considering the numbers and direction also. So that's why you have taken plus for the upward direction, negative for the downward direction. So by placing the positive and negative signs, you have included the directions here. You have included the directions here. So while you are finding the net force, you must have to denote the directions also. You must have to denote the directions also. So what is net force? The vector sum of forces is called the vector sum of all forces. The vector sum of all forces acting on the object. The vector sum of all forces acting on the object is called net force. Net force. Here sum means addition. Sum means addition. But what I called it as vector sum. Vector means here force is a, what force is a physical quantity. Force is having some magnitude, it is having some number and direction. Force is having some magnitude and it is having direction, and hence we can call this as a vector quantity. So which is having direction and magnitude is called vectors. So whenever you are finding net force, you are including the directions also. That's why I was especially represented it as vector sum. If you take mass of the object, for example, I have an object and the mass of object is 2 kgs. What is its direction? No. Speaking about direction for some physical quantities is meaningless. Speaking about the direction of the mass is meaningless. What is the time? 10 o'clock. What is the direction? No. Speaking about the direction of the time is meaningless. The length of the object is 10 centimeters. What is the direction? Length. So there are some physical quantities. Speaking about the direction for some physical quantities is meaningless. But for some physical quantities, you need to specify the direction. Force must be specified with direction. Then it will have some more information. So force is having direction. While you are finding the net force, while you are finding the total force, you are doing not a normal summation. You are doing summation which includes the direction. That's why we will call it as vector sum. That's why we will call it as vector sum. For example, let us consider a block. Let us consider a object. So let us consider a object. Someone is pushing this object. Someone is pushing this object with a force of 10 newtons. So someone is pushing this object in this direction with a force of 10 newtons, and another one is there. He is pushing with this object with 5 newtons. So one is pushing the object with 10 newtons of force in this direction, and another one is pushing the object with 5 newtons of force in this direction. What is the total force? It is not a normal summation. So you cannot make the total force as 10 newtons plus 5 newtons is equal to 15 newtons. This is wrong. So whenever you are finding the net force on this object, you need to take the directions. Here directions are not included, hence you will get an wrong answer. You need to include the directions. While finding the net force, you need to include the direction. So let us take, he is pushing in this direction. Let us take this direction as positive, and let us take this direction as negative. Let us take like that. So hence net force, F net, I was denoting it as F net is equal to, you have taken this in this direction as positive. You have considered this direction of force as positive. So plus 10 newtons plus, and second force. So in this direction you have considered this direction as negative, minus 5 newtons. So 10 minus 5. So here plus 10 newtons, plus into minus 5 newtons. So 10 minus 5 is equal to 5 newtons of force plus 5. So that is the net force will be in this direction. Why? Because we have obtained positive number here. So positive numbers is, this direction is considered as positive. So 5 newtons of net force will be acted in this direction. So this object will experience a total force of 5 newtons in this direction. So what is net force? The vector sum of all the forces. Here 2 forces are acting on it. The vector sum of all the forces acting on the object is called as net force. Okay. So let us learn about free body diagram. Let us learn about free body diagram. To find out the net force, it is better to draw free body diagram for an object. Free body diagram. Let us discuss an example, and later I will write a definition. FBD means free body diagram. So for example, there is a car here, and car has got some trouble, and someone is pushing the car. So you are pushing the car. So you have applied a force of 20 newtons in this direction. You have applied a force of 20 newtons in this direction. So since the wheels of the car is in contact with the surface, so what happens to the motion of the car? Opposing frictional force acts on it. So let us take frictional force as 5 newtons. So you are applying 20 newtons of force, and frictional force was acting in this direction. So these are the forces I have denoted. So what are the, let's write all the forces acting on this car. So let us indicate what are the forces acting on this car. So I have described the situation there. Let us denote. So 20 newtons of force is acting in the right hand side direction. So 20 newtons of force. 5 newtons of frictional force acting in the left hand side direction. 5 newtons of force. Is there any forces acting on this car? Is I left any forces? Yes, I left about weight. The weight is acting in the downward direction. The weight of the car is acting on the downward direction. So since the car is presented on a surface, the normal forces will be also there. So here the car is in contact with the road with tires, and hence there are two normal forces. So here also will be normal force is there, and here also normal force will be there. So hence two types of normal forces are there. So we can call this as free body diagram. We can call this as free body diagram. What is free body diagram? The diagram, this is the diagram which shows all the forces acting on the object. So here in this diagram, all the forces acting on the car, I have represented all the forces acting on this car. So such diagram is called as free body diagram. Such diagram is called as free body diagram. What is meant by free body diagram? The diagram which shows all the forces acting on the object. The diagram which shows all the forces acting on the object at a particular instant of time. At a particular instant of time is called free body diagram. So this is the diagram which shows all the forces acting on this car. I have shown all the forces acting on the in this diagram, all the forces acting on this car is shown. That's why this is a free body diagram of this car. This is the free body diagram of the car. So let us take another example. So there is an inclined plane. Some substance is there and an object, a wooden block is placed on this. This is the wooden block. So what are the, draw a free body diagram for this. Draw a free body diagram for this. So let us draw that. So this is the inclined plane and this is the block, wooden block. What are the forces acting on this wooden block? One is the weight vertically downward direction. Weight is one of the force, weight. And what is the another force? Normal force. Normal force is normal to this inclined plane. Normal to this inclined plane. So since the block is in this position, let us assume that block is moving in this direction and hence it will experience gravitational force in this direction. Experience gravitational force in this direction and frictional force in this direction. So here I have listed out all the forces acting on this block. Hence it is a free body diagram. What is meant by free body diagram? The diagram which shows all the forces acting on the object at particular instant of time is called as free body diagram. So let us learn about effects of forces. Let us learn about effects of forces. Effects of forces. So have you ever watched playing football in your TV? Have you ever watched playing football? What will they do is they will strike, they will kick the football. They will kick the football. So the force can bring the object in motion. Force can bring motion in object. What is the effect? So by applying force, you can bring any object into motion. So force can, so initially in the ball of football game, initially it will be kept at the center of the ground. It is at rest position and some player will start kicking it. So by kicking, by applying force, what will happen? By applying force, what will happen? They bring that ball into motion. So force can bring object into motion. So that ball can be stopped by some other player, it can be stopped. So by applying some force, if any object is moving in this direction, so for example, if you are playing cricket, a ball came to you, what will happen? You will catch it, that means you are applying some force and stopping that ball. So a force is applied to stop that ball, So a force can also bring into rest, a force can bring the object into rest which is in motion. So force can bring an object to rest which is in motion. So force can stop the moving object, it will brings to rest means the force can stop the moving object. And force can, for example, a ball is moving in this direction, again I have applied force in this direction, what will happen? The ball is already moving in this direction, again I have applied some force in this direction, what will happen? The speed of the ball increases, so force can increase the speed, So someone is moving in this direction and I have pushed him, what will happen? Suddenly he will comes in this direction and suddenly he will changes his direction, Force can increase the speed and force can also changes the direction of speed, changes the direction of motion. So these are the changes that a force can bring in an object, and there are some other changes also there. So force can change the shape of the object, So this is a temporary change. For example, if I was squeezing the sponge, what has happened? The shape was changed. So if you stretch the rubber band, what will happen? Its shape is changed, but it is a temporary change. So if you tear the paper, means if you make small pieces, you are applying some force and deforming its shape. It is not a temporary change, it is a permanent. If you break any substance with force, it is a permanent shape. And other effects of force is you can change the shape of the objects. So sometimes that force can bring a temporary change, or sometimes the force can bring a permanent change. So these are the different effects of force that you can obtain by applying force. So let us learn about effect of force, change in effect of force with area. Change in effect of force with area. So our next one is change in effect of force with area. So I think everyone has pen, right? So just take your pen. So with the plain edge, apply a force like this. So I have considered a pen, and from the sharp side, just apply. The pen is having one sharp end, one normal end. So apply force with the sharp end on your hand. Apply force, just apply 20 newtons of force. So you are applying with the pen. You have applied with the pen on your hand. So this is, let's take this as hand. So you have applied 20 newtons of force. You have placed the pen like this and applied some force. How much force you have applied? 20 newtons of force. And just reverse the pen. and apply same 20 newtons of force on your hand. So, in both the cases, which hurts you more? So, this is the case, you will get more effect, it will hurt you, it will give some pain, whereas here it does not hurt you a lot. When compared with here, when compared in the both cases, this case will have more effect, this force will have more effect on you when compared with this case. This case hurts you a lot, here effect of force is greater, the same amount of forces are there. In both the cases, same amount of force is there, but effect of force is high. So, in this case, effect of force is low. So, why in this case the effect is high and why in this case the effect of force is low? Why? Because it is related to the area. 20 newtons of force is applied on a very small area. What is the area of the nib of the pen? It is very small. So, that is why you felt the effect of force as high. So, if the area is small, if the area of contact, how much contact is there with the pen? If the nib is towards your hand, it is very small area of contact. Area of contact is less. Area of contact is small. Area of contact here, when compared with this case, here the area of contact is high. Area of contact is large. So, if the area of contact is small, greater effect of force will be there, high effect of force will be there. In this case will hurts you a lot. So, in this case area of contact is large, effect of force is low. Area of contact is large, effect of force is low. So, what is the change in effect you have observed? If the area increases, if the area of contact increases, effect of force is low. If the area of contact decreases, effect of force is high. So, this can be also called as, this effect of force can be expressed with the physical quantity pressure. Pressure is equal to force by area. If the nib is towards to your hand, you have placed the sharp end on your hand, this hurts you a lot. Why? Because the area of contact is very small. If you reverse the pen and applied some force on your hand, it does not hurt you a lot. Why? Because the area of contact is very low. So, in this case the pressure is high, high pressure is there. In this case low pressure is there. So, here if you observe, the pressure is in the numerator and area is in the denominator. So, here pressure is inversely proportional to the area. If area increases, pressure decreases. If the area increases, pressure decreases. If the area decreases, pressure increases. So, this relation we will call as inversely proportional. So, with this topic of effect of force with area, this lesson is completed. Thank you.